Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to start a new topic of discussion which is on ZigBee. Okay, so this video, firstly, I will do a quick introduction. Okay, what is actually ZigBee? Okay, so in fact, ZigBee is the pioneer of low power. Okay, so low power means that the transmission power must be less than 25 milliwatt, which is around 14 dBm. Low power also means that the device must be powered up by battery and the battery is expected to last for at least 2 years. ZigBee is also another pioneer, okay, which is the mesh network. Okay, so ZigBee, in fact, is also the first so-called mesh wireless connectivity. So basically, ZigBee actually has two first. First, low power. First, mesh network. Okay, so basically, this is the key characteristics of ZigBee. Under the ZigBee architecture, okay, we actually has three items. Okay, the first item will be ZigBee end device, ZigBee router, and ZigBee coordinator. So later on, I will explain the role of all these. So basically, this will be the objective of this video. Guys, if you're keen to know more about ZigBee, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on ZigBee. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let me quickly do a quick introduction to ZigBee. Okay, so ZigBee, in fact, is a global standard that they actually define a set of communication protocol. Okay, beside low power, beside mesh network, ZigBee also has low data rate and short range wireless network. Okay, so basically these are all the key features of ZigBee. Okay, so ZigBee is actually a wireless device. They actually operate in the 868 megahertz, 915 megahertz, and 2.4 gigahertz. So from here, you can see that ZigBee actually operate at the unlicensed band, and their maximum data rate can be up to 250 kilobits per second. Okay, so basically, these are all the features of ZigBee. Okay, so ZigBee is primarily designed for battery power application. Okay, that they actually require very little amount of data. The cost is very attractive, and the key objective is we want to have a long battery life. Okay, so in many ZigBee application, okay, the wireless device is only active for a very short time. Okay, so basically they spend most of their time in a power saving mode. Okay, so basically this is how they can ensure that the battery can last for at least 2 years. Okay, so the device most of the time will be under the sleep mode, and because of this, they actually conserve the power, and the battery life actually extend up to 2 years. So this is what it said. Okay, so as a result, ZigBee-enabled device can operate for several years before you need to replace the battery. The ZigBee standard, okay, so basically there is firstly developed by this ZigBee Alliance. Okay, so now this ZigBee Alliance actually create another alliance, which is called the Wireless Connectivity Alliance. Okay, so but most of the ZigBee feature is also under this Wireless Connectivity Alliance. Okay, so this ZigBee Alliance, in fact, will be a non-profit organization that they actually firstly established in 2002. Okay, so this is actually open to all interested members. Okay, so the alliance include hundreds of members company spanning various industry. For example, we have the semiconductor manufacturer, software developer, origin equipment manufacturer, and also the installer. Okay, so ZigBee actually adopt this IEEE standard 802.15.4. Okay, so as is physical layer and medium access control. As a result, okay, any ZigBee compliant device, they in fact also compliant with this IEEE 802.15.4 standard. Next, okay, so this IEEE 802.11 series. Okay, so basically this is actually a series, okay, for Wi-Fi standard. Okay, so this 802.11 is actually for Wi-Fi standard. Okay, so it's a family of standard. And IEEE 802.11b. Okay, so the B standard of Wi-Fi, in fact, is one of the pioneer of Wi-Fi standard. Okay, so why we want to choose this IEEE 802.11b to compare? Because they also operate in the same frequency band as Bluetooth and ZigBee. So basically, we use this 802.11b to do a comparison between the very early Wi-Fi, Bluetooth, and also ZigBee. Okay, so this IEEE 802.11b, okay, in fact, they offer the most highest data rate as compared to the other two. They can be up to 11 megabits per second. Let's take a look on this diagram here. You can see that this is actually data rate versus the power consumption, complexity, and also the cost. From the location of this pioneer of Wi-Fi, okay, 802.11b, you can see that they actually has the so-called largest data rate. Okay, however, they consume the most power. They also has the most complexity, and also the cost is the highest as compared to the other two. Okay, so basically this is the feature of the 802.11b. Okay, as you can see from here. Okay, so the amount of data rate can be up to 11 megabits per second. Okay, with wireless internet connectivity being one of its typical application. Okay, so the indoor range, okay, so basically they range from 30 and can be up to 100 meter. Okay, so basically you can see that their range is actually quite so-called further away as compared to the other two, can be up to 100 meter. Okay, but I think at 802.11b, okay, the range cannot be up to 100 meter. Typically, it's about maybe 50 meter. Okay, so in contrast, okay, Bluetooth has a lower data rate, okay, under 3 megabits per second. So you can see that Bluetooth actually sit in between the 802.11b and also ZigBee. So the amount of data rate, okay, is also in between them. So can be under this 3 megabits per second. And they actually has a shorter indoor range. Typically, okay, mostly about 10 meter, that's all. Okay, so a common Bluetooth application is in its wireless headset. Okay, so I think this should be so everybody should know that one of the key application for Bluetooth is actually wireless headset. Okay, where it enables communication between a mobile phone and also a hand-free headset. Okay, so basically you can see the feature here. Okay, for let me just go through this 802.11b Wi-Fi standard. You can see that they has the largest so-called data rate and the range, okay, up to 100 meter can be compared with ZigBee. Okay, but I guess at that time, the range for this 802.11b, I think is about maybe 50, maybe up to 80 meter. Okay, seldom reach 100 meter. Okay, so basically, I will go through ZigBee on my next slides. Okay, so ZigBee has the lowest data rate. Okay, so from here you can see that ZigBee actually has the lowest data rate, and being the lowest data rate, they also has the least complexity, okay, as compared to the other two. Okay, so along with significant longer battery life, they also has the best battery life because they actually consume just a fraction of power consumption as compared to the other two. The cost is also very attractive for ZigBee. Okay, while its low data rate make it unsuitable for high bandwidth application like wireless internet or even some CD quality. Okay, so very old day we have this CD quality audio streaming. Okay, which is for the headset, for example, which require at least 1 megabits per second. Okay, so therefore ZigBee is only ideal for transmitting simple command or collecting sensor data for IoT application, for example, temperature or humidity. Okay, so compared to Bluetooth and IEEE 802.11b, ZigBee provide the most power efficient and cost effective solution for such use case. In fact, also power. So from here you can see that ZigBee has this feature. They have the best power consumption, which means that the battery life is going to last the longest as compared to the other two. And the design in terms of complexity is also quite easy and simple configuration. Cost, ZigBee probably has the most attractive cost as compared to the other two. Okay, so basically this table here show a quick comparison between ZigBee, Bluetooth, and also IEEE 802.11b, the first few pioneer of Wi-Fi. Okay, so there are actually two types of device in an IEEE 802.15.4 wireless network. Okay, so we have this full function device and also the reduced function device. Okay, let me explain what is full function device. Okay, so a full function device, they actually can perform all the function that is actually described in the IEEE 802.15.4 standard and can take on any role in the network. If I will go through this, for example, earlier on I did mention that the ZigBee device can be as a ZigBee coordinator, ZigBee router, and also ZigBee end device. In short, the full function device, they can be any of this role. However, for reduced function device, they can only take up the role of end device, which I will explain here. Okay, so an RFD, okay, which is the reduced function device, on the other hand, has limited capacity. Okay, for example, an full function device can communicate with any other device in the network, while an R reduced function device can only communicate with an full function device. So therefore, the reduced function device are designed for very simple application, such as turning a switch on or off. They also typically have lesser processing power, smaller memory size as compared to the full function device, which I will explain all this ZigBee architecture. But over here, you can see that there are actually two types of device. Okay, so basically, full function device, which means that they can be configured as coordinator, as router, also as end device, while the reduced function can only configure as end device because they have limited feature. Okay, because of this, they actually has lesser processing power, which means that the cost is more attractive, and also smaller memory size. Okay, all these actually contribute the end device to be battery power and also having a very attractive cost. In an IEEE 802.15.4 network, okay, so a full function device that can assume the three roles which I have mentioned: the coordinator, the personal area network coordinator, okay, which is the router. Okay, so sorry, this is actually the coordinator, and this is actually like the router, which I'm going to explain later on, or device. Okay, so a coordinator, okay, is an full function device capable, okay, of relaying the message. Okay, if the coordinator is also served as a primary controller of a personal area network, okay, so therefore it is actually called a personal area network coordinator. Okay, so this actually has a bigger role as compared to the coordinator. This, you can imagine, they actually behave like a ZigBee coordinator, this as a router, and this is actually an end device, which I will quickly explain all this. So if a device does not function as a coordinator, it's simply actually refer as device. Let me go through this so that you will be able to understand. Okay, so the ZigBee coordinator, okay, correspond to an personal area network coordinator. ZigBee router actually will be a device that can act as a coordinator, okay, which is the router here. As for ZigBee end device, okay, is neither a coordinator nor a router, which means that it's an end device, which later on I'm show you a ZigBee architecture to explain the role of these three. Okay, ZigBee end device have the smallest memory, least processing power, and minimum feature, make them typically the least expensive device in the network, which I have just explained. Okay, so before I continue, guys, I hope you can help this channel by like this video. When more guys actually help to like this video will have a better chances to reach out to a larger audience. So guys, help me press the like button now. Again, urge you, if you have learned something from this video, urge you to help this channel by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly study the ZigBee architecture. Okay, so as I mentioned earlier on, there are actually three types of ZigBee device. Firstly, ZigBee coordinator. Okay, so basically you can see that this is actually the ZigBee coordinator. Typically for the ZigBee architecture, we only have the one and only ZigBee coordinator. We also have the ZigBee router, okay, which is all in purple. Okay, so basically ZigBee router, okay, they actually can help to carry the message all the way to the ZigBee coordinator. As for ZigBee end device, you can see that this all yellow color thing, these are all ZigBee end device. You can see that ZigBee end device, no one actually talk to them. They actually may talk to another router, or the router can actually talk back to this ZigBee end device, but they don't carry up the message, as you can see from here. So basically, this is what we call the ZigBee end device. This is what we call the ZigBee router, and this is why this is called the ZigBee coordinator. Typically, they are the most busy device as compared to the others. Okay, so basically, this coordinator actually collect all the message, okay, all over this dot here, and then relay back to the internet. So therefore, ZigBee coordinator is always the most busiest device. I want to re-explain this part here. You can see that these are all the end device, okay, because they appear at the end, okay, which nothing actually send it to them. So therefore, they are actually called the end device. While for router, you can see that actually someone actually sent a message to the router. So therefore, they are actually known as ZigBee router. Okay, so the ZigBee coordinator, as I mentioned, there is only one in the ZigBee architecture. What they actually do, they initiate the network. Okay, before you form this ZigBee architecture, you need to form the ZigBee coordinator first. So basically, once you form this, they will initiate all the network. They store all the information, which means that they actually collect all the information from all the nodes in the ZigBee architecture. Then they actually relay to, for example, to internet, etc. So they actually communicate with all the bridges to other network. So the coordinator here, you can see that they actually will be able to branch out to any node that is actually within the ZigBee architecture. As for ZigBee router, okay, so basically it's actually a so-called the optional component. Okay, but in simple word, they actually relay the message. They act as an intermediate router, passing on data from another device. They actually extend the network coverage. Imagine this end device, they are too far away from the ZigBee architecture, and therefore you have all this ZigBee router to relay the message back to the coordinator here, as you can see from here. Okay, so basically this is the role of ZigBee router. Next, ZigBee end device. Okay, so all these end device, why we need this ZigBee end device? As I mentioned earlier on, they will be the most simple device, which means that they have lesser processing power, they have lesser memory, etc. And because of this, they actually has low power. And once you have low power, all these, okay, later on you will realize that they can be powered up by battery. As for router and coordinator, they probably must power up by AC source, while the end device may be powered up by battery, as you can see from here. Okay, so the key feature of end device is typically they are actually optimized for very low power consumption. Okay, so you can see that they also cannot relay data from another device. As I mentioned earlier on, they don't carry the message forward. Okay, so they actually generate the message and pass it to the router. They are the cheapest device. They only communicate with the parent node. Okay, so basically they communicate with their parent node, and sensor actually deploy here. So basically all the sensor actually will be deployed at the ZigBee end device here. So basically these are all the sensor. Okay, keep this in mind. The router is helped to carry the data over to the coordinator. Next, okay, they're actually so-called contention free and also contention access. Okay, so the ZigBee coordinator actually allocate a specific time to all ZigBee device to transmit via a beacon. Okay, if there is a message to transmit, ZigBee device will wait for its turn, then it actually transmits. So basically, this is content free, which means that they don't fight for the bandwidth to transmit. The coordinator will be allocate everybody, okay, to have a specific time, okay, to transmit to everyone, okay, through a beacon. Okay, so therefore, if they have a message to transmit, then the ZigBee will wait for their turn, and then when it's their turn, then they will transmit. Okay, another one is actually called a contention base. Okay, which means that they will fight with each other in terms of bandwidth to transmit. Okay, so no need to sync, okay, because they are fighting, so we don't need to sync the time. Remember earlier on, okay, which is the contention free, okay, which means that the coordinator will allocate a time. So all the time need to be synced. But for this case here, we don't need to synchronize anything. So now, for example, if the end device want to transmit a message, okay, it will switch to a receiver and listen. Okay, if anyone is transmit, if no one transmit, the ZigBee device will transmit the message. If someone transmit the message, then it will wait for some time and listen again. So basically from here, they will listen. Okay, if there is someone transmit, then they will back off for some time and then they listen again. And again, if let's say someone still transmitting, then again they will back off. Okay, so after that, again they will listen again. So now assume that there's no one transmit, then they will send a message over. So this is actually the key difference between contention-free and also contention-based access. Okay, so let me quickly mention about the battery. Okay, so as I mentioned earlier on, all these end devices can be battery powered. Okay, but for the router, for the coordinator, they need to be powered by AC source. Why? You probably ask. Okay, keep this in mind. Okay, for example, this battery power end device. Okay, imagine this. Okay, if I'm going to use this router as a battery, okay, a battery powered router. Imagine this. I do not know exactly when the end device will talk to me. Okay, because as I mentioned that this router will help to carry the message, and I do not know when this end device will send me the message. And because of this, the router is going to be awake 24/7 because if the end device has any message, they will just send it to the router. And because of this, your router need to be awake all the time, and most of the time they are actually not sleeping. And because of this, they cannot be low power. Once they cannot be low power, then I will probably want to power up by AC source so as to ensure that the device will be awake all the time and working all the time. So therefore, for router, they will not be battery power. But for end device, as I mentioned, that they don't relay the message, and because of this, they can be powered up by battery. For example, if they have a message to send, after sending the message, they can go to sleep immediately. Okay, so basically, because of this feature, so therefore the end device can be battery powered. But for router and also the coordinator, they need to be powered up by AC source. Okay, so basically this is a very quick explanation on the ZigBee architecture also. Okay, coming to my last slides here. Okay, so the typical data rate for ZigBee is going to be 250 kilobits per second. Okay, so from this diagram here, you can see that this is actually power, this is actually the range, and this is the amount of data that I actually can send over. Let me quickly explain this. So most of the time, the typical data rate for ZigBee is 250 kilobits per second. However, ZigBee also support lower data rate, which is 28 kilobits per second. Okay, so they actually trade the data rate for extra range. Okay, because of this, let me quickly explain. If you still remember, I did mention that ZigBee is actually a low power device. Low power means that the transmission power must be less than 25 milliwatt, which is around 14 dBm. And because of this, okay, they could not just increase the transmission power. Okay, which means that for ZigBee, they could not just increase the transmission power. In order to be compliant under low power, for example, they probably will not go into 20 dBm. They probably will go into this zone here. So for ZigBee, okay, they actually can control the range by controlling the amount of data to send over. When they actually reduce the data rate, they actually has a longer range as compared to the one, okay, with a better data rate. So in short, for ZigBee, in order to go for long range, okay, they may not need to increase the transmission power. As for Bluetooth, okay, in order to go for long range, they just need to increase the transmission power because they are actually not low power device. So therefore, this convention Bluetooth, they can easily increase the transmission power in order to go for long range. But for ZigBee, because they actually compliant to be low power, okay, which means that around 14 dBm, so they probably will not be able to fall into this category. So once they fall into this category, they probably cannot call low power anymore. And hence they must look for another way to increase the range, okay, which is to reduce the amount of data. When they actually reduce the amount of data, okay, the bandwidth required also reduce. Once you reduce your bandwidth, your sensitivity actually improve. And because of this, as you can see from here, you can see that they typically has a better range as compared to the one that has a larger data rate. With this, I'd like to end my discussion. Please help to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.